Hey, have you ever looked up at the stars and thought, I'd love to visit one in person? I mean, really explore another star system. It's a thought that's captivated humanity for ages. But there's a bit of a cosmic speed bump, the speed of light. Even if we could travel at the fastest speed possible in the universe, reaching even the closest stars would take decades, if not centuries. That's where things get interesting, because today we're diving into a document from the Defense Intelligence Agency, Warp Drive, Dark Energy, and the Manipulation of Extra Dimensions, to explore a potential loophole: warp drive technology.
This document is fascinating because it delves into the weeds of a concept proposed by Miguel Alcubierre back in 1994, a way to sidestep that pesky speed limit imposed by Einstein's theory of relativity.
Okay, so no time machines are breaking the laws of physics, but bending them a bit. Tell me more.
Exactly. Alcubierre's idea involves something called a warp bubble. Imagine a spacecraft enveloped by a bubble of distorted spacetime. The space in front of the craft contracts, bringing the destination closer, while the space behind it expands, essentially moving the departure point further away.
So it's less about the spacecraft flying through space at ludicrous speed and more about space itself doing the heavy lifting, carrying the ship along with it.
You got it. The spacecraft remains stationary within this warp bubble, and it's the bubble itself that moves faster than light. This concept, if achievable, would be a game changer. We're talking about reaching stars like Proxima Centauri, our closest stellar neighbor, not in millennia, but potentially within a human lifetime.
I'm already hooked and a little terrified. But tell me, what's the catch? Creating a warp bubble like that can't be easy.
You're right, there's a pretty big hurdle. To warp space-time like that, we'd need something called exotic matter. Now, this isn't just some rare element you'd find on a periodic table. Exotic matter is theoretical, and its defining characteristic is negative energy density.
Negative energy density. Is that even possible?
It sounds like something out of science fiction, right? But it's a theoretical possibility within the framework of general relativity. Think of it this way. If normal matter has positive energy density and pulls space together, like gravity, exotic matter would have negative energy density and push space apart.
So the document suggests this exotic matter is the key to creating the warp bubble.
Exactly. It would allow us to manipulate what's called the space-time metric. Essentially, this means changing the very fabric of space-time, creating the compressed space in front of the ship and the expanded space behind it.
And that brings us to a real head-scratcher. Even if this exotic matter exists, where do we even begin to find it?
That's where our deep dive takes a turn into the truly mind-bending. The document points to a potential source of this exotic matter, a connection to the mysterious force known as dark energy.
Dark energy, the force that's pushing everything in the universe apart at an ever-increasing rate.
The very same. It turns out that dark energy exhibits negative pressure, which behaves very similarly to negative energy density, the key property of our elusive exotic matter.
So the universe itself might be powered by the very thing we need to create a warp drive. That's wild.
It's an incredible connection. And it leads us to one of the most awe-inspiring possibilities explored in this document, the potential for manipulating extraspatial dimensions.
Okay, we're going full theoretical physics here, but I'm all ears. What are extra dimensions and how do they fit into all of this?
Think of it this way. We experience the universe in 3 spatial dimensions, up and down, left and right, forward and backward. But various theoretical frameworks like Kaluza-Klein theory and string theory propose additional spatial dimensions beyond these 3. These extra dimensions could be tiny, curled up at a scale smaller than an atom, or potentially much larger than we previously thought.
So these extra dimensions, could they be the key to unlocking the power of dark energy? And how does that tie back to creating a warp drive?
That's the billion-dollar question and the heart of what we'll explore in the rest of this deep dive. The document suggests that by understanding and potentially manipulating these extra dimensions, we might be able to control dark energy and, by extension, the expansion and contraction of space-time itself.
All right, I'm trying to wrap my head around all of this. We're talking about harnessing the power of a force we barely understand potentially by manipulating dimensions we can't even see. It's mind-boggling, but let's dig into how this could actually work.
The document gets pretty deep into the weeds with a specific model called the ADD model, short for Arkani Hamed Demopoulos Diwali. This model suggests that these extra dimensions could be bigger than we thought, maybe even at the millimeter scale.
Millimeter scale, that's practically within reach. But if these dimensions are so big, why haven't we detected them yet?
The ADD model explains this by suggesting that gravity, unlike the other fundamental forces, can leak into these extra dimensions. Imagine a trampoline and think of our universe as the surface of that trampoline. We experience gravity as the indentation caused by objects on the surface. But the ADD model suggests that gravity itself might be spread out, diluted across a higher dimensional bulk, making it appear weaker in our three-dimensional world.
So gravity is like water being poured onto the trampoline. It spreads out over a larger area, becoming weaker in any one spot. That's a brilliant analogy.
Yeah.
But how do we go from leaky gravity to manipulating space-time for a warp drive?
That's where things get really interesting. The document proposes that if we could manipulate the size of these extra dimensions, we could control the amount of gravity leaking into our universe. And since gravity is intrinsically linked to the curvature of space-time controlling, gravity means controlling space-time itself.
So instead of building a giant engine to propel a spacecraft through space, we're essentially talking about tweaking the universe's settings to create a localized warp bubble around a ship.
Precisely. The document even lays out some of the theoretical physics behind how this manipulation could work. It suggests using something called the Casimir effect. Now, you might remember we talked about the Casimir effect earlier as a potential source of negative energy.
Right, the experiment with two plates that showed there's actually less than zero energy in a vacuum.
Exactly. Well, the document proposes using a similar principle, but on a much grander scale involving those extra dimensions. By manipulating the boundaries of these extra dimensions, we might be able to create localized regions of negative energy density, the key ingredient for generating a warp bubble.
This sounds like we're diving deeper and deeper into the theoretical rabbit hole here. How do we even know if any of this is remotely possible?
Well, the document does acknowledge that a practical warp drive is still a long way off. However, it doesn't just throw out wild theories, it backs them up with actual calculations. It uses something called the Alcubierre drive metric, a set of equations that describe the warping of space-time needed for a warp drive, and it explores how this metric interacts with the ADD model of extra dimensions.
Okay, so they're not just saying extra dimensions cool, let's warp space. They're actually trying to figure out the nitty-gritty details of how it might work.
Exactly. And they even address one of the biggest concerns with warp drive concepts, the insane amount of energy people thought it would require.
Right. I remember reading that some scientists said creating a warp bubble would take more energy than exists in the entire observable universe.
That's where the document throws us a lifeline in the form of something called the thin shell model. Instead of creating a massive energy-guzzling warp bubble around a spacecraft, they propose creating a thin shell of warped space-time, like a bubble wrap around the ship.
That sounds a lot more manageable. But how much of a difference does a little bubble wrap really make in terms of energy?
The document crunches the numbers, and the results are pretty astonishing. By their calculations, using this thin shell model reduces the energy requirements for a warp drive by a factor of 10 to the power of 8. That's a 1 with 8 zeros after it, an almost unimaginable reduction.
So we're going from needing the energy of a billion universes to something slightly more attainable.
While still requiring vastly more energy than we can currently generate, this reduction, at least theoretically, puts a warp drive within the realm of possibility. And the document takes it a step further, suggesting that if we can understand how to manipulate the size of extra dimensions, we could potentially generate the negative energy needed for a warp drive using something called a false vacuum.
A false vacuum. Is that like the cosmic equivalent of a knockoff handbag? Looks real, but falls apart quickly.
Not exactly. In this context, a false vacuum refers to a state where the vacuum of space itself isn't in its lowest possible energy state. It's like a ball resting on a hilltop. It looks stable, but it could easily roll down to a lower point. And when that ball rolls, it releases energy.
So they're proposing we create a tiny controlled Big Bang behind the spaceship to push it forward.
It's a rather dramatic way to put it, but essentially, yes. By creating a false vacuum collapse behind the ship, we could generate a burst of energy that could propel the warp bubble forward. Of course, this is all highly speculative and requires technology far beyond anything we can currently imagine.
But it's incredibly exciting to think about. I mean, we're talking about manipulating the very fabric of reality itself. What other seemingly impossible technologies might become possible if we crack the code on dark energy and extra dimensions? It's incredible how this document takes us from the familiar three dimensions we experience to a universe potentially teeming with hidden dimensions, exotic matter, and forces we're only beginning to grasp. It really makes you question what we don't know about the universe.
What's remarkable is that this isn't just science fiction rambling. It's grounded in real scientific principles and equations. It's theoretical physics, yes, but it's pushing the boundaries of what we thought might be possible.
Exactly. It almost feels like we're peeking behind the curtain of reality, glimpsing the underlying machinery of the cosmos. But if manipulating these extra dimensions is the key to unlocking warp drive, how do we even begin to study something we can't see or interact with directly?
That's one of the biggest challenges. And the document doesn't shy away from it. It suggests that a deeper understanding of dark energy might be the key. If dark energy is indeed a product of these extra dimensions, then studying its effects on our universe could give us clues about the nature of those hidden dimensions.
So dark energy acts as a sort of cosmic Rosetta Stone, helping us translate the language of extra dimensions into something we can understand.
In a way, yes. By observing how dark energy influences the expansion of the universe, the distribution of galaxies, and even the behavior of light, we might be able to indirectly probe the properties of those extra dimensions.
So where do we go from here? The document lays out this incredible vision of warping space-time and achieving faster-than-light travel. What are the next steps, the big question scientists are grappling with?
The document emphasizes that we're still very much in the early stages of understanding all of this. There's a lot we still don't know about dark energy, and even confirming the existence of extra dimensions is a monumental task.
It sounds like we're at the starting line of a very long and challenging race.
In a way, yes, but it's a race worth running. Even if we never achieve warp drive, the pursuit of this technology could lead to groundbreaking discoveries that revolutionize our understanding of the universe. Imagine the technological advances that could emerge from learning to manipulate dark energy or access extra dimensions. It could change everything.
It's a future full of tantalizing possibilities. This deep dive has been an incredible journey through some of the most mind-bending concepts in physics. What's the one big takeaway you hope our listeners walk away with?
I hope this deep dive inspires a sense of wonder and a thirst for knowledge. The universe is full of mysteries, and sometimes exploring the seemingly impossible can lead to the most profound discoveries. Who knows, maybe someday, thanks to the brilliant minds working on these challenges, humanity will unlock the secrets of warp drive and venture out to explore the stars.
It's a beautiful thought to end on. This deep dive into warp drive, dark energy, and extra dimensions has been a wild ride. We've gone from the theoretical edge of physics to pondering humanity's future among the stars. If this has sparked your curiosity, I encourage you to seek out more information. The universe is waiting to be explored both within the pages of scientific journals and in the vast expanse of space itself. Thanks for joining us.